file structures, and after the lecture we will be able to learn the following objectives. Understand the role of file structures. Describe high-level and low-level file handling. Explain the concept of file positions, opening files, closing files. Understand the concept of record. Explain different file operations. Let's start with a brief introduction to file structures. Files are placed for reading data from or writing data to. This includes disk files, and it includes devices such as the printer or the monitor of a computer. C treats all information which enters or leaves a program as though it were a stream of bytes, a file. The most commonly used file streams are std_in, the keyboard, and std_out, the screen, but more sophisticated programs need to be able to read or write to files which are found on a disk or to the printer, etc. To use a file then, a program has to go through the routine. Open a file for reading or writing. Reverse a portal and locate the file on disk or whatever. Read or write to the file using file handling functions provided by the standard library. Close the file to free the operating system portal for use by another program or file. A program opens a file by calling a standard library function and is returned a file pointer by the operating system, which allows a program to address that particular file and to distinguish it from all others. Let's discuss the concept of file structures. C provides two levels of file handling. These can be called high-level and low-level. High-level files are all treated as text files. In fact, the data which go into the files are exactly what would be seen on the screen, character by character, except that they are stored in a file instead. This is true whether a file is meant to store characters, integers, floating point types. Any file which is written to by high-level file handling functions ends up as a text file, which could be edited by a text editor, which is written to be high-level file handling functions, ends up as a text file which could be edited by a text editor first. Low-level input-output functions have the disadvantage that they are less programmer-friendly than the higher-level ones, but they are likely to work faster. File positions. When data are read from a file, the operating system keeps track of the current position of a program within that file, so that it only needs to make a standard library call to read the next part of the file, and the operating system obliges by reading some more and advancing its position within the file, until it reaches the end. Each single character which is read causes the position in a file to be advanced by 1. Although the operating system does a great deal of hand-holding regarding file positions, a program can control the way in which that position changes, with functions such as ungetc brackets if need be. In most cases, it is not necessary, and it should be avoided, since complex movements within a file can cause complex movements of a disk drive mechanism, which in turn can lead to wear on disks and the occurrence of errors.
Hi, this is Anil with a video tutorial for the YouTube channel Learning Lad on C programming. In this tutorial, I'm going to teach you how we can reset the file position indicator in C using the rewind function. So first I will explain you the syntax of this rewind function, then how we can use this in our program, and also what is the advantage of using this function in our program. So normally when we open a file in C using the fopen function, it returns the address of a structure of type file. This structure contains all the details of the opened file. For example, it contains the name of the file, the size of the file, the location of the file, and also the file position indicator, and etc, etc. So this file position indicator tells us where exactly we are in the file. So when we open a file in read or write mode using the fopen function, the file position indicator will be at the beginning. So if we are opening the file in appending mode, which is A or A+, then the file position indicator will be at the end of the
High-level file handling functions. Most of the high-level input-output functions which deal with files are easily recognizable in that they start with the letter F. Some of these functions will appear strikingly familiar. For instance, fprintf brackets, fscanf brackets, fgets brackets, fputs brackets. These are all generalized file handling versions of the standard input-output library. They work with generalized files as opposed to the specific files stdin and stdout, which printf brackets and scanf brackets use. Opening files. A file is opened by a call to the library function fopen brackets. This is available automatically when the library file stdio.h is included. There are two stages to opening a file. Firstly, a file portal must be found so that a program can access information from a file at all. Secondly, the file must be physically located on a disk, or as a device, or whatever. The fopen brackets function performs both of these services, and if in fact the file it attempts to open does not exist, that file is created anew. The syntax of the fopen brackets function is shown here. Closing a file. A file is closed by calling the function fclose brackets. The syntax is as shown.
Welcome to C Programming Tutorials. This is a production of YouTube channel Learnorama and the Facebook page Awesome C Programming Tutorials in High Def. If you haven't subscribed to the YouTube channel, I would suggest that you do so, because this way you will be notified of any new tutorials that I post as soon as I post. And I would also suggest that you become a fan of the the Facebook channel Facebook page Awesome C Programming Tutorials in High Def. Okay, so let's get started. In today's tutorial we are going to learn about files, how you can open files in C. In the previous tutorial we learned about what files are, why they are important, and how to what are different types of files. In today's tutorial we are going to see how you can open the files, because opening the file is the main important step that you have to do before you can do anything with the files in C or in any other language. So let's get started. First of all, in this particular compiler, if you have these files included, you don't really have to do this, but in general you will need to do this. Okay, #include stdio.h. okay. And then let's see, again, everything that so far that we have learned, any other than basic stuff, they require functions in C. C is a structured programming language. That's the reason why it has a whole bunch of functions, because function is actually, as we learned, that function does a particular job, and while using the function you don't need to know how that particular job is done. All you need to know that once how to call that function, and that this job would be done after that. So since right now we are faced with the problem of opening a file, obviously we will have to use a function to open a file. Okay, so this is the function called fopen for file open. This is the function that you need to use to open a file, and then you have to specify the path, a file name, okay, preferably with the path, and then you have to specify the mode. Okay, and this actually will open the file with this name, file name, and in this mode that you specified, mode. Okay, and it returns something called file pointer. Okay, so you have to capture that file pointer. You have to store it in a file pointer. So you declare a file pointer, and you can call it whatever you want to call it. Let's call it pfile. Okay, and then you can say pfile is equal to fopen followed by the file name as the first parameter and the mode in which you want it to be open, and we will learn what this means in a minute. Okay, now file name, it's going to be a string. Okay, you can specify whatever file you want, abc.txt, or you just say abc, or whatever you want to say you can say. Okay, and you can specify the full path, c:\abc.txt. What you are saying is that you want to store it in C drive or C partition in the root directory, like this. So it will actually open a file in this, at this particular location, in this path, which is the root directory, and with this name. abc.txt. Okay, you don't have to specify the path. Path is optional. You can just specify the name of the file, and it will go and open it wherever this application is running from. It will just open it right there. Okay, so you better know where you are running this application from. This is where it's going to create the file. Okay, if you are not sure, you can specify the full path if you want. The problem is that the path has to exist. If the path would not exist, the fopen is going to fail. Okay, and when fopen fails, it will return a null pointer. Okay, a pointer that points to address 0, which is, it's like not pointing anywhere. So it will return a null pointer. If it successfully opens the file, it returns a pointer to a file descriptor, and you don't have to know what a file descriptor is. It is of this type, file. You don't have to know about this. All you need to know is that you have the pointer to that descriptor, and you have to capture and you keep it safe, just like we did. Store it in some variable, in the file pointer variable. Okay, this is what you need to do, and that's it. That's all we need, because subsequent calls to
fprintf brackets. This is the highest level function which writes to files. Its name is meant to signify file print formatted, and it is almost identical to its stdout counterpart printf brackets. The syntax of the fprintf bracket statement is as shown. Where fp is a file pointer, string is a control string which is to be formatted, and the variables are those which are to be substituted into the blank fields of the format string. fscanf brackets. The analog of scanf brackets is fscanf brackets, and, as with fprintf brackets, this function differs from its standard I/O counterpart only in one extra parameter, a file pointer. The syntax of fscanf brackets statement is as shown here. Let's now talk about high and low-level filing operations. High-level filing operation. Files which have been opened by fopen brackets can also be handled with the additional functions. fread and fwrite function. These functions read and write whole blocks of characters at a time. The parameters in parentheses provide information about where the data will be stored once they have been read from a file. ftell and fseek function. ftell brackets tells a program its position within a file, opened by fopen brackets. The syntax of ftell brackets is as shown here. fseek brackets seeks a specified place within a file opened by fopen brackets. The syntax of fseek brackets is shown here. Normally high-level read-write functions perform as much management over positions inside files as the programmer wants, but in the event of there being insufficient, these two routines can be used. Rewind function. Rewind brackets is a macro based upon fseek brackets, which resets a file position to the beginning of the file. Fflush function. This is a macro function which can be used on files which have been opened for writing or appending. It flushes the output buffer, which means that it forces the characters in the output buffer to be written to the file. If used on files which are open for reading, it causes the input buffer to be emptied. An example is shown. Low-level filing operations. Normally, a programmer can get away with using the high-level input-output functions, but there may be times when C's predilection for handling all high-level input-output as text files becomes a nuisance. A program can then use a set of low-level I/O functions, which are provided by the standard library. Open function. Open brackets is the low-level file open function. The syntax of this function call is given here. Close function. Close function releases a file portal for use by other files and brings a file completely up to date with regard to any changes that have been made to it. Like all other filing functions, it returns the value 0 if it performs successfully and the value -1 if it fails. Create function. This function creates a new file and prepares it for access using the low-level file handling functions. If a file which already exists is created, its contents are discarded. The syntax of this function call is given here. Read function. This function gets a block of information from a file. The data are loaded directly into memory as a sequence of bytes. The user must provide a place for them, either by making an array or by using malloc brackets to reserve space. Read brackets keeps track of file positions automatically, so it actually reads the next block of bytes from the current file position. Write function. This function is the opposite of read function. It writes a block of n bytes from a contiguous portion of memory to a file which was opened by open function. The syntax of this function is shown here. Lseek function. Low-level file handling functions have their equivalent of fseek function for finding a specific position within a file. This is almost identical to fseek function except that it uses the file handle rather than a file pointer as a parameter and has a different return value. Unlink function and remove function. These functions delete a file from disk storage. Once deleted, files are usually irretrievable. They return -1 if the action failed. Now we shall discuss about the record. Records are collected into logical units called files. They enable one to refer to a set of records by name, the file name. The records within a file are often organized according to relationships between the records. This logical organization has become known as a file structure or data structure. Given a set of attributes A and a set of values V, then a record R is a subset of the Cartesian product A times V in which each attribute has one and only one value. Thus R is a set of ordered pairs of the form, an attribute, its value. Now we shall talk about the file operations. The functions deal with operations on files. The type size _t is the unsigned integral type produced by the size of operator. File pointer fopen, const char pointer file name, const char pointer mode, fopen opens the named file and returns a stream, or null if the attempt fails. Storing. To store a new file, open an existing file, or save a file, one uses the fopen brackets function. Its syntax is as shown. Creating. Creation of a file uses the same syntax as of storing a file. Its syntax is shown here. Retrieving. If the user is creating or saving a new file, you can let him or her specify the name of the file, the rules of the operating system. If the user is opening an existing file, you can make sure the file already exists, retrieve its name, and pass it to the fopen brackets function. Updating. Update mode permits reading and writing the same file. Fflush, or file positioning function, must be called between a read and a write or vice versa. Sequential. Once a file is opened, operations on the file, reading or writing, usually negotiate the file in a sequential manner, from the beginning to the end. The standard library provides a number of different operations for sequential I/O. Now in the end, let us summarize what we have learned in this lecture. High-level files are all treated as text files. In fact, the data which go into the files are exactly what would be seen on the screen, character by character, except that they are stored in a file instead. There are two stages to opening a file. Firstly, a file portal must be found so that a program can access information from a file at all. Secondly, the file must be physically located on a disk, or as a device or whatever. FP is a pointer to the file, which is to be closed, and return code is an integer value, which is 0, if the file was closed successfully. Fclose brackets prompts the file manager to finish off its dealings with the named file, and to close the portal which the operating system reserved for it. The difference between getC brackets and fgetC brackets will depend upon a particular system. It might be that getC brackets is implemented as a macro, whereas fgetC brackets is implemented as a function, or vice versa. strBuff is a pointer to an input buffer for the string. FP is a pointer to an open file. Returnval is a pointer to a string. If there was an error in fgets brackets, this pointer is set to the value null. Otherwise, it is set to the value of strBuff.